Hello everyone, welcome back to one other video in my series How to in the class CSA 120. Today's topic is Negater and Decoder. In this video I will show you how to load a previous circuit and a library in LogiSim, how to design a controlled 4-bit negator, and how to design a 3x8 decoder with active low enable input and active low output. The first thing to talk about is the 4-bit negator. It has 4-bit input and 1-bit control input. It also has 4-bit output. The purpose of this circuit is to negate the input if we want it. For example, if the input is 4, if we want to negate, the output would be -4, and if we don't want to, the output would be still 4. The circuit has two parts. The XOR gates to flip the bit, and the 4-bit adder to add 1 to the flip input. So we'll have the second complement of the input, which is the negate of that number. How do I have this 4-bit adder? Does it look familiar to you? It was actually the 4-bit adder circuit that I built in the last video. LogiSim Evolution allows you to use the previously built circuits in the new one as library. You can load the circuit by clicking on the menu bar, hit Project, click on Load Library, and select LogiSim Evolution Library. You can go to the folder where you save your circuit and select the circuit, which is the C3 video for my case. I already load the circuit, so I will cancel this one, but when you open the circuit, just hit click open. When you load the circuit, it will appear at the bottom on the Explorer pane on the left side, this one right here. And all you have to do is just click on the circuit that you want to use and place it on canvas. This circuit is controlled by the control bit input. If the control bit is active, the input will be reversed. As you can see right here, A3 and A1 is reversed, as well as A2 and A0 from 0 to 1. And then the 4-bit adder will add 1 to the reversed input, and then we'll have the second complement of the input. But if the control bit is not active, then the input of the XOR gate still remain the same, and the adder will not add 1 to that input, so we'll have the same result at the input. As you can see here, 1 0 1 0, and the output is also 1 0 1 0. How do the control bit input works? The table on the right here show you how the control bit input works. When the control bit is 0, and you can see that 0 stays 0, the value of A0 stay the same. But when the control bit is 1, A0 exclusive OR with the control bit input, and then we'll have the inverse value of the input, A0 from 0 to 1 and 1 to 0. Just to let you know that the 4-bit adder right here is not the most efficient way to add 1 to the input. You can design an incremental circuit made from 4 half adders, with the carry out bit of the first half adder becomes the carry in of the second one, and so on. And the control bit will be the carry-in of the first half adder. I used this 4-bit adder because I made it already and I'm lazy to build the incremental circuit. So let's test the circuits in the next sub-circuit right here, the negate for test. So in this test circuit, I'll have the 4-bit negator, I have the 4-bit input and the 4-bit output, as well as the 1-bit control input. The 4-bit input, I put the radix at the sign decimal. I do the same for the output. Please note that with sign decimal and 4-bit, you can only have the value from -8 to 7. But you can see that you cannot go below -8 or above 7. So let's try the input of -4. As you can see, when the control input is 0, the final input is still the same with the input. But if I click on the control bit input, the circuit would flip the initial value and we would have 4. Let's see. It is 4 as expected. Let's try maybe one more time. Another one. Let's try -7. We'll have the input is -7 and the output is 7. When the negate 4 is activated, if I click on the control bit input, then the final output will be the same with the input. And that's it for the 4-bit negator. The second circuit for today's video is the decoder 3x8. A decoder is a combinational circuit that accepts a binary input and produces an output in some other form. So for this 3x8 decoder, we have 3-bit input, represent unsigned binary number from 0 to 7, and 8-bit output from Q0 to Q7, also represent the unsigned binary number from 0 to 7. Note that in this design, X is 1 and X0 is 0. So if you want the value of 4 or Q4, the binary form of 4 is 1, 0, 0. So we have the product term X times Y0 times Z0. The purpose of this decoder is that it produces only one active output for one combination of the inputs. For instance, the circuit is being active and the input are 1, 1, 0, which is the decimal value of 6, so Q6 is being active. Note that Q6 is active even though the value of the output is 0. It's because this circuit has active low output as well as active low enable input. You can see here the enable input pin, the value is 0, but the circuit is being activated. We change this one to 1, then the circuit will not active anymore and all the output will not be active, which is 1 in this circuit. Once again, let me remind you that this circuit is active low output, so it means that the output is active if the value is 0. If the enable input is 1, then the output are not active, so they are all 1. Why did that happen? You can see if the enable input is 1, the NOT gate flip the 1 to 0, and the 0 go to the NAND gate. Everything end with 0 is 0. So the NAND gate will have 0 and then NOT. So we'll have the 1 output. The design can be extended to a larger input with NAND gates, with the number of input equal to the number of input bits plus 1. So in this circuit, we have the NAND gate has 4 input pins. If we have a 4 times 16 decoder, then the NAND gate would have 5 input pin, 4 for the input bits, and 1 for the control or the enable bit input. This circuit is active low output, so I use the NAND gate. If you want to have active high output, then the only thing you have to do is just replace the NAND gate with the AND gates. Alright, that is how this 3x8 decoder works. Let's test this out in the next subcircuit. In this subcircuit, decoder 3x8 test, we'll have 3 bit input and 1 control bit input, the enable bit, and we'll still have 8 bit output from Q0 to Q7, and this is the decoder 3x8 I designed in this subcircuit. Let's test it out. So you can see right now the enable bit input is 0 and the value of the input is 0. So the 0 output is active at 0 because it is active low. All the other output are 1. If we change the value of this one, for example like 110, the value of the input is 6, so Q6 is active. We change this one to 101, which is 5. Q5 is active. But if I change the enable input to 1, then the output are all 1, regardless of the input. I can show you why I put the enable bit on top. It would be a lot easier to see the pattern with the analyze tool and LogiSim evaluation. As you can see here in the truth table, when the enable bit is 1, the value of all the outputs are 1, regardless of the input. And then if the enable input is 0, which is active, the circuit is active low. So we only have 1 active output at a time, 1 for each combination of the input. And the active output would make a diagonal line like this. So seems like that the decoder is working properly. But what do we use these decoders for? They are very useful in fact, especially for implementing canonical sum of products and product of sums equations. For example, this decoder is active low, so if it is being active, then it only produces 1 low output at one time for 1 combination of input. So for example, if you want to build a circuit that accepts 3-bit input and produce those output with the decimal value of the input is 2, 3, and 5. Then the only thing you have to do is connect those 3 output together with a AND gate, since we are doing product of sum. So the output are low if the input is 2, 3, or 5, and that's it. That is how you can use the decoder to produce or design a circuit from an equation or from a truth table. Decoders are also very useful in designing computers. It plays an important role in the communication between CPU and the peripherals, which are the input or output, like mouse, keyboard, monitors. Only one input or output is selected at one time, so you can use decoders to select which input or output is being selected. Decoders are also very useful to decode binary numbers to display on a 7-segment display, but I will save that content for another video. And that's it for today's video. Thank you for watching and hope to see you again. Thank you. Have a good day.